Okay, so we're going to talk about parent functions transformations. Now, we have already done this once before, so I'm going to go through this pretty fast. If you have more questions about what I'm doing, please go back and watch the previous unit in which I cover every single one of these parent functions. Okay, so on the first few examples, we're just talking about describing the translation and then graphing the function. So if you remember from last time, okay, that means down four. So 1, 2, 3, 4. And this is going to have the key points that are -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. However, if you remember this from Algebra 1, that's your y-intercept, and your slope is going to be 1. So this is going to look like this. And to describe the translation, we're just going to write down 4. It is a linear. Maybe I should write that. Yeah, no, I'm not going to write it. I'm just going to leave it like that. Then for the next one, remember this is an absolute value, and we're actually going to take this left 5. So we're going to go to the left 5, 1, 2, 3, 4, 5. And if you remember for the parent function, y is equal to the absolute value of x, we had the following key points. Okay, now if I decide if this is this point right here, which I want to call my fake origin, remember this is 0.00, so this is points, I'm going to pretend like this point is 0, 0. The next one is going to be 1, 1, which is right here. If this is 0, 0, 1, 1 is right here. 2, 2 would be right here. -1, +1. If this is 0, 0, -1, +1 would be right here. And then -2, +2 would be right there. Remember the absolute value looks like a V. Okay, and that's it for that. Now for the next one, we have a quadratic. And remember the parent function for the quadratic, the key points would be -2, -1, 0, 1, 2. And to get the y coordinates, I'm just going to square every x. And I'm squaring every x because this is the function, x squared. So it's telling me what to do to get the y. So if I square the x, I get the y. 4, 1, 0, 1, 4. Okay. Now, all this means in this one, we're going to go down 3. And then we're going to graph this, right? So we have that right there. Again, I understand that I'm going pretty fast. Please go back and look at the previous unit if you have trouble with this. All right. Moving on. Now it says describe the dilation in each function, then graph the function. When it talks about dilation, it's talking about either a vertical compression or shrink or a vertical stretch. Okay, so for example, 5x, that's going to be a vertical stretch by a factor of 5. But we're just going to say it's a vertical stretch. All right, so it's going to be a vertical stretch by a factor of 5. So this will be 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5. Okay. Positive slope, y-intercept is 0. So it's going to look like that. All right, for this one right here, this is going to be a vertical compression or vertical shrink. And how do I know it's a shrink over a stretch? Remember, if the number in front of the function is less than 1, then it's going to be a vertical shrink or vertical compression. If the number in front, like this one, is bigger than 1, then it's going to be a vertical stretch. Okay. So this one right here, if we graph it, I'm not moving left to right, so I'm going to start at the origin. I'm going to follow the same points that I have here, but all of the y coordinates are going to be multiplied by a half. So instead of 1, 1, I'm going to go 1 and up a half. For the next one should be 2, 2. Now it's going to be 2 and up 1. So 2, up 1. The same thing here. Looks like a V, looks like a V. And then finally this one right here, this is going to be a vertical. Is the number bigger than 1 in front of it? The answer is yes. So this is going to be a vertical stretch. And if you just want to write in your homework stretch and not vertical stretch, that's fine for Algebra 2. Down the line in pre-cal, you might have to do other stretches that are horizontal, but I guess you'll find out when you get there. Same points as Let's see, the next one should be 2, 4, so it's going to be 2, 8. 2, 8 is going to be off the graph. So can't really graph too many points on this one. Again, I'm using this table, and I just multiply all the y coordinates times 2. Okay, so again, make sure to watch the previous section if you have more questions on that.